Hey, folks, good morning, good evening, good afternoon, and good night, wherever you are in the world. You are joining us here live, and I am joined with the one, the only Mr. Adam Culp, who will be sharing with us today effective and clean application development. Adam, mate, how you doing?
I'm doing great. This is awesome. I'm first time using StreamYard and looking forward to share with the folks. And thank you all for being here.
Yeah, thank you, everybody. Please remember, you can let us know what your questions are. So when Adam's finished with his presentation, we will try and hit him with some of those questions if there is some time. Otherwise, we will, of course, circle back with you over on Facebook. If you're not sure who Adam is, then Adam got started in high school, back with the basic programming language and a Radio Shack TSR-80. And if you know what that is, let us know in the comments. During the military, he was exposed to a great deal of hardware with a real-life rocket science-based roommate. And fast forward a couple of decades or so, and Adam joins us today with a wealth of experience in hardware and software development. The cool thing is you can find out way more about Adam over on YouTube at Beachcasts. So, Adam, I believe you're here with a presentation. People don't want to hear from me, they want to hear from you. So let's throw that up and I will let you rip, buddy.
Sounds good. Sounds good. Thank you very much. Thanks for the introduction. So again, this is Clean Application Development. I am Adam Culp. And one thing that people learn about me really soon on is that I am a huge fan of iteration. I love iteration. It's in everything that I do. Everything that we do as developers is iterative, whether it's iteration from evolution. We learn to walk. From learning to walk, then we learn how to run. Evading project managers, that's also iterative. We get better at it over time. And in clean application development or clean development is exactly the same thing. It is iterative. It's something that we get better at. It's something that we hone and just work into our daily lives. So unfortunately, it's not something that can really be taught. Clean application development can't be just taught in a few minutes or even in this talk. However, I'm going to do the best job I can to give you a lot of hints and a lot of tips to help you be able to embrace it. Above all, just make sure that you're constantly practicing, constantly doing. The best way to learn is by doing. So please do things, constantly code, constantly try new things and learn as you go. One of the things that I like as well is the old idiom of leaving things cleaner than you found it. The old Boy Scout motto, leave the campground cleaner than you found it. And always watch out for new techniques. There's a lot of new things out there to try. I'm constantly trying new things. That's one of the reasons why I created Beachcast on YouTube, is because as I try new things, I like sharing them as well. So I share them there. It's not the most professional of video outlets, but I do enjoy doing it. So I hope you all enjoy it as well. There's no silver bullet as far as clean application development. It's a lot of things put into practice. There are a few books that I recommend to folks to help with this. One of those is Clean Code by Robert C. Martin. You may have already been aware of this. If not, it's one book that I would highly recommend that you read in relation to the code itself and going that route. Now, I also share a kind of a story with this of, what are some of the things that happen? What ends up resulting in, bad code or unclean code? There are many different reasons why it comes about. One is it's easy. You just have to do less. And so we as humans tend to be a little bit lazy in most things. So coding and having bad code is just something that happens just because it's easier. Short deadlines is another possible reason that we end up taking shortcuts, or we end up not going back and cleaning up as much as we would like to. Again, programming is iterative. I don't know any developer who's able to create the best from the very beginning. Instead, they create, then they go back and refactor, then they iterate over that and refactor until the point where it is nice and clean, or as clean as they can get it at the moment with the time that they've been given. So Short deadlines always hinder that. Bosses also can kind of hinder us from being able to create the best thing that we can, because of course they are defending those timelines. And if they're defending the timelines, they're fighting to make sure that everything gets out in time, make sure they take care of business, keep the business people happy or the customers. And so bosses can also kind of help result in a bad situation. Laziness, again, going back to that, the first one, which is easy. It's easy to create, things in a non-clean manner. Laziness is also another attribute that can cause that. Lack of how to. We all in technology are learning on a constant basis. Every single day, we're learning something new. If you're not, please do, because but the lack of how to is a big contributor to not having the cleanest application, not having the cleanest code. So we have to constantly learn. We have to always look for better ways to hone our skills and be able to do things in a better way. And then we always make the promise of, I'll come back later and clean it up. And we know that doesn't happen, or at least not often. So try not to do that as much as you can be.
I'm
But
guilty of that
above
one the
all,
most.
as we're looking at all these things, right, when it comes right down to it, we are the cause of the bad code. We're the cause of an unclean application, because all these things basically come down to us being able to accept it or not. So imagine, if you will, you hire a brand new developer. Everybody, as they're starting a new job, or developers as they first start out, they all have this ideal in mind that they want to create great applications. They want to help people. They want to create the cleanest application they can. And when you hire a developer, they're basically have a clean slate. Now, imagine, if you will, there's no application existing. The developer is going to start creating it from scratch. So the developer's hired fresh. The boss kind of shares some of the vision with them, and him or her, and indicates what they would like to have built. So the developer runs off and starts coding and creates something pretty quickly because there's excitement involved. And then they come back, they show the boss what they did, and the boss is impressed. He's like, "Oh, okay, that's great. That got finished pretty quickly. It took you a lot less time than I thought it would be." So then the boss, of course, they come up with the next idea. They're like, "Oh, well, what if we tweaked this, and what if we added this?" So the developer, in their excitement, they go back and they code it again really quickly, and they're like, "Oh my god, let me hurry up and do this. It's a great idea. I want to make sure I get it in." And maybe the developer doesn't pay attention to the most recent coding standards. Maybe they don't pay attention to the most current conventions. They're in a hurry. They want to make their mark. They want the boss to be happy. They want business to be satisfied. So they put it together, and then they go back to the boss. And so what happens through that process is it's a back and forth thing. The developer iteratively goes back, creates something new, brings it to the boss, and iteratively, pretty soon the boss starts getting conditioned to this. And the boss is like, wow, wait a minute, if I give the developer things, or if I make suggestions, they're just going to run off and do it and bring it back, and they're going to be excited. They're going to do it pretty quickly. But unfortunately, the developers in their haste, are doing these things very quickly. They may not be implementing tests. They might not be implementing some of the best practices, because they just want to get it done quickly. They want to satisfy, their supervisor or the business or the salespeople or even the customers. And eventually, that catches up to them. Eventually, it catches up to them. It's just a domino effect, where once the dominoes get stacked to a certain degree and you bump one, now all of them just topple over, and then the application turns out not to be so great. It has a lot of bugs in it, has a lot of issues. And that can't be even, I can't overemphasize that enough, especially when we come into the busy seasons where we want our applications to perform quickly, but yet we've spent the whole year doing this sort of thing where we've added more technical debt throughout the year. And then it comes time for the big push at the end of the year for, Black Friday, Cyber Monday. We need the application to be fast, and it's not. Or we need features to be done on time for this big busy weekend, and it's not. So that's something. Just keep in mind that this is building clean applications is iterative. It's something we do over time, but it's something that you can't just overnight do. It's something that has to be done on a regular basis. Now, our job as developers is to say no. The thing is business is going to push on you. The customers are going to want new features. The salespeople are going to sell things ahead of time before it's even done, and they're going to tell you, "Oh, by the way, this is sold, so I need it done quickly." These things happen. However, we as developers, our job is to uphold the professional opinion. Don't be afraid to push back a little bit, right? The manager's job is to defend the schedules, defend the features. Our job is to defend the code and defend the application. So don't be afraid to say no. But that being said, don't be the person that always says no and can't provide a real reason of why you're saying no. You have to have all your ducks in a row. Make sure you have realistic reasons and explanations of here's why I'm saying no. And that can be difficult. Developers sometimes don't even know why they're saying no. They just know that they have to say no because they know they're going to be programming themselves, and shooting themselves in the foot with the programming. But always be prepared. Do your homework. Be prepared to come with good detailed explanations. Above all, remember that your application is your calling card. As a developer, there are other people that are going to be looking at your code. Developers spend about 90% of their time reading code and about 10% creating code, right? So that means 90% of the time, developers are going to be reading what you've created in order for them to be able to then go and add new code, be able to add new features. So we are authors in a sense. It's code and people are going to be reading it. So therefore we're authors. And just keep in mind that other people are going to be reading it and they're going to talk about it. And that's where a lot of people can lose some credibility, right? Because if other developers are going to read it and they're going to be talking about it, you don't want to develop that sort of reputation for yourself. So take pride in what you do. Enjoy the code, enjoy the process of creating it, and do it as well as you can. Now, if you've gotten into a situation where you do have this bad code, what happens? I mean, typically, some of the side effects of getting yourself into this sort of situation, right? First off, you're going to be wasting a lot of time because now you've got to go back and read the code more in order to implement something new, or in order to fix a bug, in order to add some feature, you've got to spend a lot more time reading. You also have to spend a lot more time planning, because you have to plan around the spaghetti that you've created up until that point. Maybe there are bugs. Bugs will take more time because then you have to spend more time on bug fixing versus doing new things that the business is desiring. It also can result in a lot of excessive debugging, because if you've got issues with your code and you can't find it readily, you have to do debugging and step through your code to see, okay, where is the problem happening? How did this come about? It can also lead to procrastination. Nobody likes to work on things that they don't really enjoy. And if an application has gotten to the point where it's not really clean, we don't enjoy it. So we're probably going to procrastinate a little bit and not spend as much time doing new things as we would like to do. And it's going to cause missed deadlines as well, because if you're procrastinating, you're not going in and attacking things when they come up, you're going to end up missing some deadlines. Or worse yet, you're going to tell somebody that, oh, that's okay, I can get this done in a couple months, and a couple months go by and you still don't have it done because you kind of missed the deadline. It should have taken a couple months in a clean stack. It should have taken a couple months with clean code, and adding new features. Unfortunately, that may not be the case. So it can end up with a lot of missed deadlines. It can you can also end up in a situation where you're adding more technical debt than you are more clean code. If you've got a bad application and you haven't taken the time to clean it up through iteration and through refactoring, all you're going to be doing is adding more technical debt as you go in order to compensate for that. And ultimately, it can cause financial loss. If the company is expecting new features for their customers and they want to sell these new features so they can bring on more new customers, it's going to cause financial loss because they're not going to be able to get customers as quickly. They're not going to be able to make sales as quickly, and it just hurts everything all the way around. So how do developers compensate for this? We know the side effects now, but how do we compensate for that? What I often find is a lot of developers tend to pad their estimates. How many of us have been asked, okay, how long will it take? So we think in our mind, I think it'll take a week, but you don't say that, do you? Instead, you say, it'll take 2 weeks. you pad it, you double it. I've heard many developers, as they're giving time estimates, they'll say, well, yeah, first I calculate how long I think it'll take, and then I double it, and that's the number I tell the customer. Well, if you think it's going to take 6 months to do a feature, and you go back and tell the customer it's going to take a year, that is 6 additional months only for uncertainty. So we end up with a lot of padded estimates. Developers tend to hide. Customers are calling saying, hey, I needed this new feature. Where are you? What's going on? How far along are you? And the developers start to hide. They don't answer the phone anymore. They let everything go to voicemail, or they don't answer the emails. So these are some of the side effects of getting into this sort of situation. Developers can also become defensive. As human beings, if people are constantly asking us questions and we're experiencing frustration because we don't have the answer, it causes a lot of times some defensiveness. And we all know that there are developers out there who have developed a reputation for themselves of not being, or being more introverted and not being friendly. And when in reality, maybe they are very friendly people. They've just gotten backed into a corner because of the situations that they've ended up in, and they become more defensive and they seem less like a team player, when actually they're probably a great team player. They just need to understand the process a little bit more and how to make clean applications. And then we can always, and there is always the blame game as well, where one developer will say, well, Joe did that, or Mary did this, and it isn't my fault. I only did the best I could with what I had. So you end up with a lot of blaming back and forth and a lot of politics, and it can create for a really bad atmosphere. So a lot of businesses, a lot of development teams, what they do is they start throwing more developers at the situation. They're like, oh, I need to hire 10 more developers in order to get this feature in 6 months, or in order to get this new application in a year. So they add developers, they just throw them at it. But maybe they didn't need more developers. Sometimes that can even compound the problem if you have developers tripping over each other inside the code and not working optimally. So you end up with all these new developers coming on. The old developers, they start doing less because they know they can now. Now there's more resources, more human resources on the project. And then, of course, in a very extreme situation, the only answer is rewrite the application. You've got a bad application, time to rewrite it. And that brings in its own endless loop of issues and things like that. So now, when it comes to having an application like this, I don't recommend rewriting, and I have a lot of opinions on that. But what I do recommend is refactoring. I recommend iterative refactoring. Now, I've got a book on this. There is a book by Martin Fowler called Refactoring: Improve the Design of Existing Code. And this book is priceless. When I experienced this book, I guess it was probably, now I've been a programmer for over 20 years. And about 17 years ago, somebody recommended this book to me. And I read this book, and it changed my life. It changed the way that I program. It changed the way that I think about programming. So I can't recommend this book enough. Get this book, read through it. Now, the first half of the book is good quantitative substance. The second half of the book is kind of an explanation of various refactors and step-by-step approach of how to tackle them, what they are, and how to tackle them. So that's something that I don't necessarily read through, but I did read through the first half of the book, and it did opened up the second half for me to use as I need to. And but yeah, great book. Now the thing is I've kind of been describing the bad situation. I've kind of been talking about a lot of the bad things about dirty application development, right? Well, the thing is why do we want all these bad things? Why do we continue to do these things? Why are we doing this? When if we were to do clean application development, we could kind of turn everything around. We could shorten our development time, having a better and cleaner application. It would be easier to onboard developers because as a new developer is coming on board, they understand the code a lot better. They can read the coding standard, get ideas of how things are done within the application. It makes them able to come on board a lot faster. The application will have less bugs. We'll end up with happier end users, not to mention happier bosses. I have more predictable schedules. So when somebody comes with a new feature, it's a lot easier to give an estimate and not have to pad it. And it's just a professional thing to do. We as professionals, as developers, we are professionals. Just like when you hire a carpenter or you hire a plumber, we are a developer. That's our job. That's our profession. and we should be living up to that. We should be as professional as anybody else and able to do things in that way. Now, one of the things that I said throughout this is that there are different tools that can be used, different things that we can implement to make this job a little bit easier. One of those is a coding standard. In PHP, I recommend that you look at the PHP Fig, the PHP Framework Interoperability Group, and check out the different PSRs that are there. There's a lot of different things out there to help standardize. The most modern frameworks, most libraries out there are using the PHP Fig, standards and conventions, and I'd recommend you take a look at them on your projects as well. Now, I will say that I'm not saying that you have to use this one. I'm not saying that you necessarily even should use this one. But above all, build a coding standard, have a coding standard for you and your team, and then implement it. Pick one and move forward. Don't spend too much time arguing because everybody has opinions and everybody will always choose their own standard. I personally choose the PHP Figs because I have to choose one. I have to have something. Now, granted, it's not perfect. No coding standard is, but I don't have to maintain it. It's there. It's already there for me. It doesn't make sense to me to create my own, create all the documentation, create all the wiki and everything else just for the coding standard when PHP Fig's already there. And it just makes sense to use it and not have to go through it. Like I said, it's not perfect, but no coding standard is, depending on who you talk to. Everybody has their passions. So anyway, I'm going to kind of go through a few things that do make sense in common code usage, regardless of the coding standard. And these are some of the things that I use throughout my coding and throughout my applications. One of them is making sure that you have good names. Naming is difficult. Naming is very hard. So I make sure that I have good naming conventions throughout, instead of giving things generic names like elapsed or create days, modified days, or age. Those can be subjective, and we don't really know exactly what those are. Maybe instead of elapsed, we could say elapsed time in days. That's a very clear, definitive name. Maybe instead of created days, we could put days since created. Adding a little bit more clarity to it and so forth. I'm not going to go through each one, but it's always good to create more definitive names, things that are clear and we can understand at a glance by reading them versus, looking at it and not being quite sure. Another thing to do is as you're coming up with these names, don't use different names throughout your application. So for instance, if I had a product variable and it was containing an object of products or containing an array of products or whatever, I wouldn't want to have product info somewhere else and product data somewhere else. What's the difference between those? What's the difference between product info, product data, or even product description? Those don't really make sense. So what I do is as I'm using a name in one place, I try to use that same name throughout. I don't redefine it. And by talking with all the other developers on the team, on the application, we all work together to make the naming more consistent. So that way we don't end up with product in one place and product info in another place. And what do either of those even mean? So those are just some things to keep in mind. Again, in that same vein, as you're using names and characters, you want to be cognizant that some characters can look the different or same depending on whether it's capitalized or not. So some things that I try to stay away from is using a lowercase L, or using, because a lowercase L can look like an uppercase I. It could be like the exact same thing, or an uppercase O could look like a 0. Depending on the character set that you're looking at. So just be cognizant of those and try to make clear naming where you can understand these characters a lot better. If I see a word that has a lowercase L, it's obvious that it's going to be a lowercase L. I can't mistake it for a 1 or an uppercase I, because again, it's a word. So just be cognizant of certain characters and how they might be hard to understand. And of course, looking farther into the code, if we look at in a object-oriented space, it's good. it's good that we have our class names, being nouns. So if we're trying to solve a problem, a class should solve a problem, right? And so if as a class solving a problem, if I have a class and I name it customer as a noun, I know that that class is going to solve the problem of customer, whatever that means, or might solve the problem of account or problem of product or company. It just makes it nice and clear to read that. Method names within the class then should carry verbs, because the method, while the class solves a problem, the method does one thing towards solving that problem. A method should only do one thing. You don't want a method that does too many things. You want to keep it nice and simple. And by naming it as verbs, if I have something like get customer, close account, update product, add company, those things are verbs. They're taking action, and it's very clear in the naming of them. So naming is very important. Some additional things in relation to naming: make sure you keep your functions very short. Like I said, a function or a method should do one thing. It doesn't really take a lot of lines of code to do one thing. If you find that your functions are getting really long, chances are you're doing more than one thing. You can break that out into a couple different functions that are doing one thing. They should be very single purpose. You should also be able to look at a function and pretty much at a glance understand what it's doing. At a glance. If you can't look at a function or a method at a glance and be able to tell what it's doing, chances are it's too complex. Most of my methods are very short, very easy to read. At a glance, I can tell what they're doing, and they're not really doing anything too. They're not being too tricky. They're not being too complex, and they are pretty much as I expected. I can look at a method name and say, okay, here's the method name, is eligible for full-time benefits. And I can look in that method and pretty much tell, yeah, that's exactly what I thought it was going to do, because the methods are kept very short. Also, as we're going through, just as an example of whenever we're listening to music, we can listen to music and we can understand whether music is good or bad. I can listen to a song and say, yeah, that's a pretty good song. I like that. But it doesn't mean I'm necessarily a songwriter. Just because I know that the song is good or bad doesn't mean I can write the song, but I understand that it's good or bad. Our code can be much the same thing. By putting in recognizable patterns and things, we can look at the code and tell, oh, that's pretty good code. Or we can look at the code and say, wow, that is horrible. I can hardly read it. I don't understand what's happening. So one thing to keep in mind is as you're looking at code, if you look at it and if something just doesn't seem right from the very beginning, go with that gut instinct. Something needs to be cleaned up there. Something needs to be changed or refactored. Just kind of go with that. Now, unfortunately, as programmers, we are songwriters and programming, so we know how to fix it. Versus listening to a song and it's bad. I don't know how to fix a bad song because I'm just not a songwriter. So just keep that in mind. And also another item that I like talking a bit about is code comments. Please leave comments inside your code. Comments are really important. You should have comments in your code. I've seen more and more people who are not putting comments in their code. It makes it really hard for people following behind you. Now, that being said, keep your comments very simple. You don't want to make your comments too complex. You don't need to write a book. It's not a wiki, it's code. But what I do recommend is that rather than explaining the code, because business people aren't going to be reading the code. They're not going to be coming behind you and reading the code. Programmers are going to be reading the code. So instead of explaining the code that they already should be able to know, they're programmers. Instead, in the comments, describe what the code is supposed to do, the deliverable. What is the intent of the code, and that's what you comment. Is adding the intent of the code, very brief, so that way the person following behind, they can look in the code and they can say, well, wait a minute, what's that supposed to do again? They can read the comment. Oh, okay, there's the intent. Now I understand why it's done that way. Hopefully the code was simplistic enough that it didn't need that to begin with, but having the intent of the code documented along with the code just makes it so much easier. Now, as an example, if we were to look at this code example here, so in this code example, we're looking at it, we have an if condition. This is PHP. So we have an if condition, and we're looking at the employee flags, and we're testing to say, does it exist? And is it an hourly flag? And does the employee age, is it larger than 65? Right. So that's an if condition. And now here we had to put in, the test to say, or put in the comment to say, check to see if the employee is eligible for full-time benefits. Now, on the other hand, if we broke that if condition out instead and put that in a method or a function call, we could maybe put it in the employee with the employee class and name it is eligible for full-time benefits. Now, looking at that, if I had a method that was named is eligible for full-time benefits, do I really need to go look at the method to see what it's doing? Or can I tell by the name what it's probably doing? So again, naming is really important in code comments. You want to make sure that you're not over commenting. Sometimes just the names themselves will be enough. Along with that, there's a lot of other code smells as well as code comments being a code smell. There's a lot of different ones. I'm not going to go down through each one of these. Just know that there's a lot of them out there. I encourage you to read into code smells. If you don't know what code smells are, definitely check them out. Code smells are where there might be some code that is not the best it can be, right? So you're inside the code, you can find things and some certain characteristics like incomplete error handling or inconsistent coding standards. Maybe the names are long, maybe the names are not descriptive and things like that. So it's code smells. And now that doesn't mean a code smell is bad. It doesn't mean that when you look at code and you see a code smell or you smell a code smell, it doesn't mean that it's bad. It just means that there might be a chance that something needs to change there. Doesn't mean it has to change. Just means you might want to pay attention to it. Now, there is a tool in PHP a couple tools which work out really well for that. One is PHP Code Sniffer. Recommend you use PHP Code Sniffer and have that integrated into your deployments, as well as PHP Stan. These are two great tools for running analysis on your code. The application doesn't have to run. These actually analyze the code line by line and look for common smells to see if there's something that might need some attention. Now, by the same token, I've created a Docker image for these as well. If you go out to my GitHub account, github.com/Adam Culp, I have one out there called PHP Code Quality. It's a Docker image, makes it drop dead simple to be able to run these tools using a Docker container. You don't have to change your application. You don't have to change your web server, whatever you're using for development. It does it all within Docker and gives you an output file of the results. So you can see if Code Sniffer or PHP Stan can highlight any bugs or any potential code smells for you. I highly recommend it. Check that out. I've got about 11,000 users of that Docker image right now. And so it seems to work really well for a lot of people. And there's a lot more code quality tools in there other than these two. So check that out. Now, another great way to help with clean application development is through peer reviews. For many, many years, as I've been developing, I've always had other developers in my local network of friends that I can reach out to and say, hey, can you take a look at this code? And have them do a friendly peer review. By having somebody look at your code, it gives a fresh set of eyes that aren't looking at it the same way as you. And they might find some new things. They might find some refactors that maybe you want to implement into your code, or there might be some ways that you can improve it. I highly recommend that you implement coding reviews in your normal pipeline. So I've worked at a couple of different companies where we did this, where as somebody was doing the coding, they would commit it into the repository. After it was committed to the repository, they could not merge that code into the main branch or the master branch, whichever naming you're using. And they couldn't do that without somebody giving it a code review first, because it's that important. It is really important to make sure that your code is being reviewed by someone else, because we can't always see everything. And oftentimes we kind of accept it because we understand it. We're coding on it for a prolonged time period, so we understand it a lot better. Now, another way to help with this and make sure that your code is of a good quality is through patterns. If you've not used patterns in your code, I highly recommend that you look at them. Chances are you've already been using patterns and didn't realize it because they just kind of happen. Here's another book that's one of my top 3. I've got all 3 of them in this presentation. The Design Patterns book, Elements of Reusable Object-Oriented Software by the Gang of 4, they called themselves, or somebody named them Gang of 4. But either way, it's by 4 different developers. And the design patterns in this book are really helpful for software. I encourage you to read it. Now, that doesn't mean that as I'm coding, I can verbatim start, creating these patterns, but it's good to understand the patterns, and it's good to know that they're there and they can help you solve software problems a lot faster because the pattern is already in your mind. Now, one word of forewarning: this book is don't read this if it's close to bedtime unless you want to sleep, because I did take a lot of naps reading this book, but it's a great book, and it's very educational to understand the coding patterns in object-oriented coding. Imagine it this way. Imagine that, you have a building much like this one, right? If we look at this design, we can see that there are rows and it looks like maybe some sort of shelves. We can see that there's some kind of reading room there and some other things. We can kind of look at this, and based on the patterns, we can tell that it's a library. Or if we look at patterns of maybe some other buildings, some other architecture, you can kind of tell by looking at these pretty much what they do. And that's where patterns come in. Patterns are just ways that are predictable. These problems have already been solved before, and we can implement these patterns to help solve the problems for ourselves. And then, of course, don't be afraid of reusing somebody else's code, right? In PHP, we have the composer, which is a dependency manager. We have Packagist, which is a way you can do it privately or use the public repository for using open source code. I mean, don't be afraid to use other people's codes and bring in other projects into your application. Now, certainly vet them and make sure that there's a good amount of contributors, make sure there's not a lot of issues. Usually those are public and open source, so you can see those. But don't be afraid to pull in some of those projects. It doesn't make sense to go out and recreate the wheel if the wheel already exists. You can pull it in and use it in your application. You have the benefits of a lot more eyeballs on the code than your team or yourself. You have a lot more, a lot more support in the back end. You can always reach out to folks, reach out to some of these open source maintainers. Now, don't overbear them, right? It's good to ask questions. It's good to ask them if they can help you out, but realize they're developers just like you. Chances are they develop these open source packages and put them out there for other people to use. It doesn't mean that they're there for support. It doesn't mean that they're going to be providing active support, unless you're reimbursing them somehow through sponsors or through some other mechanism that they've put in place to allow themselves to become your support level. But that being said, don't be afraid to use other libraries and packages. And for clean application development, it just makes sense. Why not pull it in? Why not allow the upgrades to happen easier? I don't need to create the lines of code required for these packages. It just makes it a lot easier and a lot easier to get your application up and running faster. Why would I want to recreate a package that does what Guzzle does for HTTP within an application? I'll just pull in Guzzle and let Guzzle do it. I don't need to recreate that. I don't need to spend all that time on the project development. Oh, wrong way. We also want to make sure we're testing our code. And testing is really important. So there are a few testing frameworks. PHP Unit is one of them. There are some other ones out there. But anyway, make sure that you're testing your code. If you're not testing your code, you should be. And please try to get there. The thing is by testing your code with some sort of unit testing, you ensure that much of the base scenarios, much of the things that you want to do are going to be tested. So if at any point your code breaks, or if any point somebody says, hey, this isn't working as I thought it would, you can run your unit test and say, okay, well, it's running according to the test. So how did you expect it to work? And maybe you need to create more tests to compensate for that. Now, if unit testing is really important. So if unit testing is really important, it just makes sense to try to do it first. Now, I realize not a lot of people are doing test-driven development. Not a lot of people are able to write the tests first. But if testing is really important, it's a good goal. It's a good benchmark to try to reach out to do your testing first. So I would encourage you to do that. And the nice thing is by creating your tests first, when it comes time to write the code, well, first off, uh, in order to be able to write your tests first, in order to be able to write tests in your code, that does require that you have good requirements. If you don't have proper requirements of the application, if you don't know what the application is supposed to do because business hasn't given you enough information, or you just don't understand enough to create, you're not going to be able to create tests. So you have to have those things. You have to have good requirements. You have to fully understand what the application is supposed to do. And then you can write the test easily. You can say, okay, well, I know the application is supposed to do this. So let me write a test that does that. And then once that test is there, then you just go back to the code. You just have to write the code that satisfies the test. Then once the test is successful, you've got good code. And you'll find that if you get to that point, you'll find that you write a lot less code, because now you've not only have you got better requirements, but you only need to write enough code to make the test pass. We as developers tend to add in a little bit too much at times. If your tests are there, you can keep your code very simple, and it makes it a lot easier to understand. Now, by the same token, when it comes to testing, a lot of developers in a professional atmosphere, a professional situation, usually have a quality assurance department or QA testers. And unfortunately, what happens is developers oftentimes they code and they say, okay, well, I'll have this done in 2 weeks, right? 2 week sprint. In 2 weeks, then they're throwing the code over to the QA engineers and saying, okay, there you go. Now you can test it. Well, wait a minute. It was due in 2 weeks. And now you've got the QA engineer getting it the day before it's due, or the day that it's due. So it's a really bad situation. We end up with the case where the QA engineers are kind of just at the end of the train and they aren't ready for it. Because it was given to them at last minute, and it's just not a good situation. So try to get things to them early enough so that they have time to properly test it. And if they find a bug, then you have time to properly fix the bug. Now, in some teams, I've even seen where QA engineers are kind of at the beginning of the process instead of the end. QA engineers are actually helping write unit tests based on the requirements, and then they give the unit test to the developers. The developers write the code that makes the test pass. That's all there is to it. And then you're basically putting the QA engineers back toward the beginning. Now, a lot of people in that same vein have adopted Agile or something like that, where it's a lot more precise, everything's a lot more documented, everything's a lot easier to do. So one of the things to keep in mind is whether you adopted Agile or not doesn't matter. One thing to remember is when you are building something and you've given a timeline for it, it's not done until everything's done. That means that your code is done, your tests are done, any other development, and the documentation. A lot of developers forget the documentation. They forget the test. They just put it together and they throw it over to QA. Well, that's not programming. That's not developing at all. And you certainly didn't finish on time if that's all you're doing. So you have to have the test. It has to have the documentation. Your QA engineer should have everything. It should be all right there for them. Business should know how to use it once it's completely done. Then you have a finished application. Then you've lived up to the delivery date that you actually gave them. If you're not living up to that, if you're not doing the documentation or the tests throughout your development process, then you're not doing programming. That's not what programming is. Programming is all that. So that way you're giving the end user, you're giving the QA engineers everything that they need so that they can do their jobs, or they're able to be satisfied and then be able to put something in front of their customers that will continue making money that pays your salary. So keep that in mind. Keep it going well. Make sure you're doing everything nice and gracefully. And by the same token, if you're not able to get things done on time, that's perfectly okay. There's nothing wrong with being able to say, I'm sorry, I'm just not going to be done in time. However, please do that early. Don't wait till the last minute and say, oh, it's not going to be done. You have to give business time to gracefully recover. They need to be able to go back to the customer and say, hey, Mr. Customer, Mrs. Customer, I'm sorry, we're just not able to have this done on time. It's going to take 2 more days or 1 more week or whatever the case might be. Please do that. Above all, as I said earlier, we are professionals, just like a carpenter, just like a doctor, just like anybody else that has a profession. We are programmers. It's our profession. And we should be delivering at that same level as well. It's you want to be trusted. We need to have reliable estimates. We want to make sure that we're delivering quality and also making it so that we're replaceable. And by being replaceable, not only can we take vacations without having to worry about the pager in our pocket, but we can also get promoted because now they're not relying on us. We've helped share knowledge with other people. So in summary, for clean application development, there's a lot of pieces to it. I've covered some of them, certainly haven't covered all of them in this short talk, but clean application development is about learning, constantly picking up new things, understanding new technologies coming, repetition and iteration. It's going to happen iteratively. It has to. You can't get everything done right from the very beginning. And make sure you practice. Do new things all the time. Always be curious. Make sure you're creating clear architecture. Use patterns, use some known patterns, or develop some of your own patterns so that people can look at them and understand what's happening. Makes it a lot easier to understand. Use a coding standard. Make sure you use a coding standard. Define it. If you're working on a team, your entire team should use that coding standard. And keep in mind that everybody's not going to agree on everything. Sometimes you will disagree, and that's perfectly fine. But after you disagree, you have to make a decision and move forward. Whether you agree with it or not, make a decision, commit, and move forward and live up to whatever decision the team has made. If you can't, then you need to move on. But that being said, the entire team needs to use that. Use frameworks, use code from other people. It just makes sense. There's no sense in recreating the wheel if it already exists out there. Instead of complaining and saying, well, it doesn't do this little thing that I want it to do, instead say, okay, how can I change my way of thinking so that I can use this code? It doesn't make sense for me to create a framework of 500,000 lines of code or even 1 million lines of code if it already exists. Let me just use it. Make sure you're doing testing. Use some sort of project management. Learn how to say no. Learn how to defend the code. It's your application. You're a professional. They've hired you to be a professional. Part of being a professional is knowing when to say no, knowing when to push back. But above all, make sure you're providing good reasons why you're saying no. Don't just say no and then walk away. Say no, but here's why I said no, and let the business make the decision. This is all that makes up being a professional, and clean application development is created by professionals, and it should be all of us. So here's a little bit more. My name again is Adam Culp. You can find me on Twitter at Adam Culp. Please feel free to hit me up with any questions, or if you follow me on Twitter, you'll see I do tweet some things occasionally. I have a technical blog at geekyboy.com. I have a podcast, which is highly not used, but I'm getting ready to start some new episodes at Run Geek Radio.
Awesome.
I talk a little bit about running and a lot about programming. Beachcast on YouTube, please check that out. And then there's references to the other 3 books, which I think are the 3 books that every developer should have on their bookshelf, which is Clean Code by Robert C. Martin, Refactoring by Martin Fowler, and the Design Patterns book by the Gang of 4. Highly recommend that. So thank you very much. I hope all of you found this helpful, and feel free to reach out to me if you have any questions or anything.
That's awesome, mate. Thank you so much, folks. I just want to share a few things that stuck out to me, and thank you, Adam. This has been phenomenal. The first one is that your application is your calling card. We are authors, and we don't want to lose the credibility with our readers. So that reminds me of how much pride I want to take with my code, because other people are going to read this, which is phenomenal. I love the way you phrase that, mate. The next one is the technical debt side of things. I'll often make a few decisions on code and go, oh, it'll be okay. But actually, that will eventually lead to some technical debt, and I'll either pay that price or the client will, or worst case, both of us will pay that technical debt. Also, a reminder on functions, I will often try and cram too much into a function. So being able to put one thing, make a function do one thing really well, perfectly obvious, as short as possible.
You know what I
Another,
do with
yeah,
that, with my functions, what I do as I get older, my eyes get a little bit worse. So
yeah,
what I've done is I've set my font in my editor to be like a 20 or a 22 point font. I don't use these
perfect.
little tiny letters. I use nice big letters. And what I've found is that my editor shows about 30 lines of code.
Yeah,
And that's really all I need. If my function is longer than my screen, which is about 30 lines, I've got an issue. So I have to fix that. And so
absolutely.
so that's just something that I do personally.
Well, on eyesight as well, that's my next thing, which is be careful of case, because L's can look like capital I's, etc. And that's something I struggle with all of the time. Two more points was don't be afraid of other people's code. So why reinvent the wheel? And I also dropped a link as well to your GitHub, buddy, for people to check
Thank
that
you.
out. So do check out the comments, folks. And also remember, do subscribe as well to YouTube on Beachcasts. And finally, something I need to go and read into, which is a phrase I've never heard of, is code smells. So I highly recommend, folks, that you go again, subscribe and go and learn about those code smells. They're not always going to be bad, but it's certainly good to be aware of them. Folks, remember that we are doing this all week as part of the Prepathon by Cloudways. So whichever medium you are watching or listening to us on, please subscribe and please keep following along throughout this. They're all being recorded. You can check out over on the YouTube channel. That's youtube.com/Cloudways. You'll be able to see all of the replays. And I highly recommend that you put this one at the top of your list, because personally, I think this was the best. Finally, coming up in about 10 minutes from now, so stay tuned on whichever platform you are, is tips and tricks to get your online store at pace for the holiday season, starring the one and the only Brendan Tully. So that is 10 minutes from now, 12 p.m. CST. Adam, thank you so much for your time. Look forward to consuming more of your videos and telling my team to follow you. So thank you and have a wonderful day.
Thank you. Thanks for having me.
Cheerio.